break.
Yeah, okay.
For the next talk, yeah.
Good,
okay.
Good. I did a movie yesterday. I will show you afterwards a simulator, but I think I start with the movie because I have the connection now. And then I show you the simulator afterwards. So here I run that. So this is, I think with sound, you should hear the sound with that. Huh?
Professor Schwitter, are you in the presentation mode or not?
Yeah, now it's presentation mode. Yeah.
Okay.
Can you see that?
Yeah. It is okay. Yes. Okay.
And can you hear the voice?
Hello, everybody.
Yeah.
We start with the demonstration.
Do you hear the voice?
Not much.
Hello, everybody in Athens.
Now it's better.
The simulator, how it works.
Okay, so I show you what we recorded with Etienne yesterday, and then I show you when I do a little intervention in 2 minutes.
And first, you see here the interventional MR unit, which is used for currently atrial flutter ablation in our new center. And then you see here the simulator, and I have the pleasure to introduce you Etienne Pruvot, Professor Pruvot, which is the head of the unit of interventional electrophysiology, and he will explain you how the simulator works.
Okay, thank you, Jürgen. Good afternoon in Athens. It's my pleasure to show you the Imrico ablation vision MR catheter, which is made, as you can see, of an handle that you can use to bend the catheter. And if you look at the catheter itself, it has different components. First of all, you can see two gold electrodes. The distal gold electrodes has holes to perfuse sodium chloride during the ablation. Then there is a second recording electrodes, and within that blue line, there are two receivers to really be able to record the signal. So now, if we take a look at the tip of that ablation catheter, you can see that it is made of a line, as a matter of fact. And if I bend the handle, as shown here, this is producing a plane. So I'm able to steer the catheter in a plane. And now if I apply a rotation, I'm able to steer the catheter in 3D within the volume of the heart, which is the principle of steering catheter in electrophysiology.
Thank you very much, Etienne. I think this was a very good explanation what you will do within the virtual heart in a minute. Thank you very much.
Perfect. Very educative.
Yeah.
Good for education.
So now, hello again. Now we are showing you how you can do this isthmus ablation, flutter ablation in the simulator. And we will start with the first step of that by the cannulation of the coronary sinus. And Professor Pruvot, he will show you how we can do that in this simulator here. Please, Etienne.
Okay, all right, very, very good. Thank you, Jürgen. So let me explain you what is shown on this screen by the simulator. So what you have here is an open view of the right atrium and the right ventricle from an RAO point of view. And here in yellow, those yellow tags are the tricuspid valve, for instance. This is the coronary sinus and the ostium of the coronary sinus. And those light yellow tags are tags placed along the cavotricuspid isthmus. And this is the second view, which is orthogonal to the first one, where you can see the coronary sinus with a target to be reached here. You can see the different tags along the cavotricuspid isthmus that the fellow has to reach in order to achieve ablation. And this is these big tags you can see on the left side. you will note that there is also some internal view as seen by the tip of the ablation catheter. Here you have a typical flutter, right? And you have two different scenarios shown there. This is an focal right atrial tachycardia, and this is a typical right atrial flutter turning around the tricuspid annulus and exciting the left atrium from right to left.
Very good, Etienne. Thank you for this clear demonstration. So now we want to treat this typical atrial flutter in the simulator. So please go for the first step. Show us how you do it.
Yes, the first step is to now, as potential trainees, to be able to catheterize the coronary sinus. So I will take this real Imricor ablation catheter and I will introduce it through a femoral introducer, which is a real one, into the simulator. And you will see on the left part of the screen the arrival of the ablation catheter into the inferior vena cava, which is now the case. And you can see that by pushing forward, I can move along the inferior vena cava and enter the right atrium. I can even go to the superior vena cava and pull back as with a real ablation procedure. So the first step here is to enter the coronary sinus. To do so, first thing is to bend the catheter, as I'm showing you here, bending by using the handle. Then I'm steering clockwise the catheter. Now I'm on the tricuspid annulus, and you can see here that I'm going to be able to enter the coronary sinus as shown there. And there, now I've achieved the first step of the procedure, which is entering the coronary sinus. Then I can unbend the catheter. Therefore, I can go further into the coronary sinus and I can pull back and come back to my inferior vena cava and then my right atrium.
But that's great, and I think you did it in a quite fast way. And we see that you do that for many, many years. Thank you very much, Etienne. We will continue soon with the ablation of the isthmus. Thank you.
So this is the last one that we will show for the isthmus. Huh?
Hello again, dear colleagues in Athens. Now we go to the second part of the flutter ablation procedure. And Professor Etienne Privot, he will show you how to use the simulator to do a nice ablation line in the cavo-tricuspid isthmus. Please, Etienne, show us how do you do it.
Good, thank you, Joe. So I just want to show you the pedal that has been designed, right, to really like a real ablation pedal in order to deliver high frequency to the tip of the ablation catheter. And this pedal is used to deliver, let's say, artificial energy. So now we move to the screen. We get back to this RAO view with an open view of the right atrium. And I'm going to bend the catheter, right, using the handle. And now I will try to hit those targets, right, which have been placed along the cavo-tricuspid isthmus. So now I'm getting closer from these targets, and you can see that I can get it on it. And this is the first one I wanted to reach, which is just behind the tricuspid valve. And the force which is applied now is around 1 gram. So I can try to optimize that force by bending stronger and turning a little bit counterclockwise, and I'm reaching 3 grams. Of course, I could get much stronger force if I was using a guiding sheath. So now I will try to hit the second target. So I have to steer a little bit counterclockwise up, and I'm on it now. And I have a force of 5 grams, which is pretty good. And now we'll try to hit the next one. As you can see that I'm going towards the coronary sinus. So what I will do is counterclockwise, and you can see that it's jumping like in real time, in real life. But now I'm on the third target with 9 grams of force on it. So now I will try to jump into the coronary sinus. I try to hit the following target, which is getting more and more difficult. So in that case, I will try to, okay, pretty good, turn now a little bit clockwise in order to reach it. And you can see that it's not that easy, right? So I just touch it. But you got the principle here, which is really how to learn how to steer the catheter with clockwise rotation, counterclockwise rotation, and bending in order to be able to move in 3D within the right atrium and the other cavities. So I can even show you that you can use some typical ablation maneuvers where we do almost a closed loop in order to be on the station valve. And I believe we are done, Jörg.
Yeah, I think there is, maybe I give you a second, and in the meantime, I would show you the tip of the catheter. And at this tip, we could test an additional coils for the imaging procedure. So we will show you later during the course images that we can do with the tip of the catheter while Etienne is going for the last point. And yeah, nice, you got it. Okay, very good. Thank you very much, Etienne. It was a pleasure to see you. And I can tell you, not every fellow that started with the simulator did it this way, but towards the end, they improved. But you see, we see that you do that for 20 years now.
That's true. So thank you, everyone, and greetings to Atif.
Thank you very much. Bye-bye.
Okay.
So I prepared, I asked 2 people to be here for a little demo, like 5 minutes or so. They are there. I asked Nora Bacher, who did the study on all these electrophysiologists and non-electrophysiologists, and I asked Uda Ranga, who is one of the engineers who put a lot of brain work into the simulator. So if you agree, I will just show these 2 people to you, and then we go to the break. I think so I think you can, if I go this way, you see, I go to the, so here you see where we work, huh? And then we go this way. So we go into the preparing room here for the intervention. If we turn by 100 degrees, you see the intervention room with the material that you need to convert the diagnostic room into the interventional room. And if I turn again, we see here the simulator, and the people are not yet here. Uda Ranga?
Yes.
Hello.
Hello.
Hello. I do it this way. Hello.
Yes, hello.
Okay. Hello. And maybe Nora, you come here as well, because I announced you. Hi, Nora.
Hello.
Hi, Nora. So these are the 2 guys which put a lot of work into development of the simulator. So Uda Ranga is from Addis. So he put with his team all the efforts to create the simulator with some raw data from hearts from our side. And Nora did all the work on this training study that I presented to you with. So she was able to get all the doctors to the right time to the simulator and to work on the simulator, because they had about 2 weeks of training each to get to the point where they could perform the simulations. And maybe I would like to ask just a minute or so, Uda Ranga, to maybe you can say us a little bit what is inside this fantastic machine.
Did you show it?
Yeah. Okay. No, I did not show the machine so far. Huh?
So yeah, if you can show it. So here you see the simulator. So there is, if you just turn a little bit, here you have the leg part of the simulator, and here it's the head side. And what we have here is like, as with a normal patient, we use real catheter. It's a physical real catheter. But in the simulator, what you can do is that you can maneuver this physical catheter inside a virtual heart. What does that mean is that it enables you to swap hearts. Any patient you want, you can load the 3D model of the patient's heart into the simulator, and you can navigate your physical catheter inside the virtual heart. So the whole challenge was to figure out how to do it. So because we have, it's basically based on augmented reality technology. You have part physical, part virtual. So it's a combination of these two aspects, what we have developed here. And the 3D model of the heart is coming from MRI or CT. You use the MRI or the CT to extract the 3D model, and then we loaded it into the system. And in the system here, you see like it's a chamber, basically an empty chamber, where you maneuver the physical catheter. We track this physical catheter and we move it inside the virtual heart so that it reflects a virtual scenario where you are doing maneuvering and ablation inside the chamber of the heart. Yeah, so that's more or less it.
Maybe I can ask you. You said empty box, and this was quite astonishing for me, because here this simulates like the magnet, and the patient is inside here, and the heart, but there is no heart inside. But the catheter stays inside the heart. It doesn't go out of the heart, but there is no physical heart in that chamber here. Can you explain for simple minds what does this mean, or is it too much of proprietary information?
So what I could say is that how can I say in a clear way? So from maneuvering the physical catheter, what you are showing, because in a catheter, for instance, this catheter, if I can take it out, you can see it can do set of basic motions. So you can bend the catheter, you can twist and push, elongate the catheter. So we basically track these key maneuvers of the catheter, and so the rest is the technology we developed.
Okay, so you learn the AI what the catheter is doing if the electrophysiologist is bending and so on. Yes. He bends the catheter in this chamber here, and AI learns what this bending means. It transforms that in 3D space, and then
put it in the.
Then you know where you are in the heart.
Yes.
Because the heart is also in 3D space.
In 3D space, but here, since there is no heart, it would be outside the heart. So the whole thing is how to figure out how to put it inside the heart.
Okay, so the real catheter, which is in this chamber here, is transformed by AI more or less in real time.
Yes.
In a 3D catheter, which is digital.
Yes.
It's not real anymore. So then it can enter the non-real heart.
Exactly.
Okay. So I think that's a little bit what is inside. I thought I would try to ablate for you, but I think you saw how Etienne is doing it. It would be more or less difficult for me to show you that I cannot do it. So I think we recorded the interventions yesterday, and you saw how it works. You can choose different scenarios, different hearts that you can prepare beforehand, and so you can go through a predefined training program if you want, and you can test by the output measures. So thank you very much, Udaranga. Thank you very much, Nora. She's a little bit shy, but you don't need to be shy. Your work was great, what you could do, and so this is what we do. And I think this is also nice to show this orientation. You see here the simulator, and then in here you see the same thing in real again. So I think that's so you can train here a real patient data. You can do several interventions here, and then you invite the patient, and you do the same thing with the same visualization tools in the real patient. So that's something that we like to do more often. Thank you very much for both of you. And I think with that, we could show you a little bit what we do here.
Great. Okay. Very advanced center. Very nice experience. So, Sophia,
Yes.
what is next?
Just few minutes break to drink water, whatever.
How
And
many?
then 5:30 is Dr. Lupi.
Okay,
Okay.
very good. 5:30.
Okay.
See you